Hello and welcome to my channel, where in this series I take you guys through past VCAA Maths Methods exam questions, providing you with my full work solutions, as well as touching on any of the common mistakes or pitfalls that people made, and I'll provide any other tips where I can along the way. So in today's video we'll be running through question 4 from the 2020 Non-Calc exam. It should be up on screen at the moment. Before we dive into the question, we're going to have a quick look at the examiner's report. So we can see this question is out of a total of 3 marks, with the average being 1.8 and only 26% of people getting full marks for it. So in my opinion, nothing too tricky, except you can see it's a log question. So sometimes people tend to forget those log rules and indice rules when dealing with exponentials as well. So it's really important to have a strong understanding of that. If you do, then you shouldn't have too many problems with this question. Great. So let's jump right in. So if we're trying to solve for x here, solve the equation 2 log base 2 of x plus 5 minus log of base 2 x plus 9 is equal to 1. So trying to find x, how are we going to do that? So we need to obviously combine the logs. And hopefully you guys remember, if we've got the subtraction of 2 logs, then we can divide what's in the brackets as long as that they have the same base, and they're both base 2 in this instance, so we can do that. And if the other sort of rule that you should keep in mind, not relevant to this question, but if this was a plus, then we can do the same thing, but instead of dividing them, would be multiplying what's in the brackets there. The other rule that you might recall is, so I'll just write this off to the side, so 2 log base 2 of x plus 5 can also be written as log base 2 of x plus 5 squared. And really, we should probably have squared in there to differentiate between squaring the whole log and squaring what's inside the log, like that. So hopefully that's nice and clear. So combination of both of those rules, this being sort of the first step, and then the second step, the subtraction of the log, which ends up being division. So what we should have is we'll have log base 2 of x plus 5 squared divided by x plus 9. And that's going to be equal to the right hand side, which still stays the same as being 1 there. Great. So from here, what we can do is we can rearrange it in terms of the exponential form. So we're going to have 2 to the power of 1 is equal to what's in the brackets of the log. So we're going to have 2 to the power of 1, which is obviously just 2, is equal to x plus 5 squared divided by x plus 9. And then if we just rearrange some terms, so multiply this denominator by both sides, we're going to have 2x plus 18. I'm also going to expand out what's in the numerator, so we're going to have x squared plus 10x plus 25. And then if we put all the terms to the one side, so I'm going to make the right hand side the stuff that doesn't have the 0, so I'm just going to subtract 2x and 18 from the left hand side. So we're going to have x squared, 10x minus 2x is 8x, and then we're going to have 25 minus 18, which will be 7. You can see we've got a quadratic here that should be able to factorize. This one's relatively straightforward, so we're going to have x plus 7 and x plus 1. So therefore, that gives us 2 solutions. X is equal to minus 7, or x is equal to minus 1. Great. So some people may stop there. If you stop there, you're probably only going to end up getting 1 or maybe 2 marks if you're lucky. One of these solutions is valid and the other one isn't. Now, to demonstrate graphically which is valid and which isn't, if I sort of just draw a Cartesian plane real rough here on the right hand side for you, and if we look at both of these logs individually, sort of what are we looking at? So if we look at log base 2 of x plus 9, we know it's going to have a vertical asymptote at x is equal to minus 9 and the function exists for x is greater than minus 9, right? So we know this here is something like log 2 of x plus 9. Great. So where does the other function exist as well? So the log 2 of x plus 5, so we know this 2 at the front is just a dilation from the x-axis, so it's just going to scale the y values. So if we just, to make a good comparison, instead draw in, so this will be x minus 5, and here we're just drawing log base 2 of x plus 5. Great. So which regions do both of these functions exist for? Well, we can see between minus 9 and minus 5, it's only the function in blue that exists. So therefore, this other solution can't be valid. So that's sort of a graphical representation of why it can't be valid. So we can also say, it's good to sort of state a brief reason, or at the bare minimum say it's not valid and identify the fact that this solution can't be possible. Not valid, I'm just going to say not valid, as x is greater than minus 5. It must be greater than minus 5. So therefore, our final solution is going to be x must be equal to minus 1. That's the only valid solution there. Great. So sort of went through the common mistakes for that one. Just to reiterate, it's after you get to this step where you've got two solutions, you need to confirm the validity of both of them. We could see by doing a simple sketch that the only valid region was that x had to be greater than minus 5. Therefore, that only left us with the one solution. If you can get your head around all that, then you shouldn't have any issues answering this question. I'll leave it there for this one. Thanks for watching the video, guys. If you got anything out of it, please leave a thumbs up, share it with friends or classmates. If you're new to the channel, then I'd really appreciate it if you subscribe for more content like this in the future. Lastly, I do take video requests, so if you guys have any questions, feel free to leave them in the comment section below or to email me at yourmathquestions@gmail.com. Thanks for watching.